So for question 28, this is a rational function, a very complicated denominator. So you can see denominator here is very complicated. So they say the first thing you have to simplify because this rational function is not a simple, is not in a simple form. So you have to simplify it. If a rational in a simple form, you have to see the numerator and denominator clearly. So it cannot be in the fraction got fraction, in the fraction got fraction. So that one is not a simplified fraction. So our simplified fraction must be in this kind of pattern. One things at numerator and another things at denominator. Simple. Okay, so for this, how we going to simplify? So for first, we will write it clearly first. Uh, 1 over 1 plus 1 over. We will simplify the fraction here first. We get to the same denominator so that we simplify this fraction under the denominator for this 1 over. So for this fraction part, additional fraction part, we get to the same denominator which is x, so it becomes x plus 1. Okay, so we simplify the fraction, addition of fraction here, and then 1 over this thing. So when I say 1 divided by x plus 1 over x, so actually it will be equal to 1 times inverse this fraction, 1 times x over x plus 1. So for this part, 1 divided by this fraction, it will give you x over x plus 1. And then again, we simplify the fraction for this addition fraction. So for the addition fraction, we will get it to the same denominator. So this denominator multiplied by x minus 1, x plus 1. So numerator also become x plus 1, then plus x. So again, it is 1 over a fraction. 1 over a fraction. Alright, 1 over this fraction. So it is equivalent to 1 times inverse it. So x plus x is 2x. So therefore, here we can get x plus 1 over 2x plus 1. Then after that, only we evaluate, find the value when we substitute the value of 1 over 2. So it will be 1 over 2 plus 1 divide 2 times 1 over 2 plus 1. So this one you can press your calculator. So for the first part is how we simplify this fraction. And then second part, we come to the answer. Then we substitute our value of 1 over 2 in order to evaluate f 1 over 2. So for question B, they say, please find the domain of fx. The domain of fx is a set of real number except 3 number. So find out what is the 3 number. Then we should go back to the original fraction here. You can see for rational, we always remember denominator cannot take 0. So we can see how many fraction here. Here a fraction. Then here a fraction. Then here another fraction. Then here another fraction. Then here another fraction. So we can see three types of the different fractions. For the first fraction, you can see here. So for the first fraction here, you can see here, the denominator is x. So means that in our domain, denominator cannot be 0, right? So denominator cannot be 0. So for the first fraction, the denominator is x. So x cannot be 0. That will be our first fraction coming up from here. Then after we simplify, you can see after you simplify, it is after we simplify 1 over x plus 1 over x, it is another fraction. It is x over x plus 1. So from here we can see our denominator is x plus 1. So from here x plus 1 also cannot equals to 0. So x cannot equals to negative 1. Another part of the fraction which come from this fraction. Alright, and then we continue another fraction at here. So another fraction at here, we see the denominator, or this denominator same as just now lah, x plus 1 cannot equal to 0. And then when we simplify this fraction, the final simple form of this fraction is x plus 1 over 2x plus 1. So denominator part here cannot equal to 0. So that's why our x cannot equal to negative 1 over 2. So the question said the domain of x is a set number except 3 number. So what is this number? So the number will be 0, negative 1, and 2. So except these 3 number. Okay, so this straight to the answer cannot be 0, cannot be denominator cannot be 0. This is basic. Then another one, denominator, yes. So this is how we get 4. The K is a concept we always find back. Where's your denominator? Where's your fraction? We refer our fraction. Cannot be 0.